Electricast.
How many discounts does USAA Auto Insurance offer? Too many to say here. Multi-vehicle discount, safe driver discount, new vehicle discount, storage discount, legacy.
How many discounts will you stack up? Visit USAA.com/auto discounts. Restrictions apply.
Hilton brings you new ways to stay, with experiences that let you capture the glory days. Introducing the Graduate Hotels. Each inspired by local college towns, these stays are always original and never boring. Get in touch with traditions all across the country and enjoy a stay that's a class above the rest. Book at Graduate Hotels with Hilton Honors Points at Hilton.com. It's a win-win. Hilton, for the stay.
It's really a race. Once you launch your game, it's a race to build your player base faster than your runway. Because if your runway runs out, then the game goes away. It's as simple as that. How do we make the images you generate feel smooth? And how do we mitigate the conflicts that come from the synchronization between the player and the server? And that is netcode.
Hello, and welcome to Brain Arcade. I'm your host, Chris Cross, and I'm here with Ken Anderson of Tashi. Today, we're going to talk with Ken about the technology that he's working on at Tashi and how that's going to change or affect your experience, even though you may not know what it's doing. Ken, why don't you tell us a little bit about yourself and a little bit about Tashi?
Yeah, sure. Well, I'm Ken Anderson, as you introduced me. I'm a software architect by trade, but also a serial entrepreneur. And my thing is always just trying to find the next problem to solve. Right now, I'm highly focused on reducing the cost of game development. And if I do my job right, then we're going to get a whole bunch of cool things coming out of the back end. But hopefully nobody who's playing games knows that I've done my job if I've done my job right. Only the developers will be aware of it.
Right, like me. So I met Ken at GDC and we got talking about his technology, and we probably had one of the most like two wizards talking about spells conversations that anybody would ever witness. But tell me a little bit more, like a lot of people may not know what software architecting is. And I think maybe it's sort of break that out into sort of more layman terms.
Yeah, so my job is to, it really is solving problems with software. There's so many tools out there that you can use to build software these days. I mean, even if you're a game developer, are you using Unreal? Are you using Unity? Are you using Bevy or Godot? There's just so many tools involved. And then once you kind of get into those tool stacks, there's so many ways to build your software. Are you building it heavy on the server and light on the client? Are you building it heavy on the client and light on the server? So there's all these decisions you have to make. My job is to really figure out what the most optimal configuration is for the problem at hand. So depending on the type of game you're building, you're going to want to have a different type of software architecture. And so that's really what I do, is I kind of pull together the software pieces. And currently we're actually building some of the pieces, some of those building blocks themselves that help make game development more affordable for the developers and actually take some of the constraints out of the picture to make it more available to even the end users, whether they know it or not. All they'll know is that they'll have a better gaming experience. And that's all that we really care about.
Right. And so the way this works with me on the game design side is I work very closely with architecture so that I can understand what features and capabilities and game actions we're going to allow people to take. And there's usually like some horse trading where I say, hey, I want this. And Ken says no. Or he says, oh, but you can have this. And I'll say, oh, I hadn't thought of that. Let's actually add that feature. You know, like, why don't we actually break down Fortnite in like 30 seconds of like, as an example, right? Because like Fortnite has like, it's server based, which means that there's a network and it's feeding the client information. The client is on your console or your PC or your phone because they have mobile as well. And then basically those two computers are talking to each other to provide you with an experience. You know, and some of the things when it's not working well, people will experience it as the all-encompassing lag, hitching, stuttering, you know, like poor rendering because they're not getting enough information. But there are lots of ways for this to be bad for players. But, you know, how that is architected heavily determines what kinds of bad experiences you can have. And what Kim was saying earlier is if he does his job right, you never knew he was there.
Yeah. I mean, ideally, you're just playing your game and enjoying it, and you're not having hit reg problems if you're in a shooter. I think Roblox is like probably one of the better examples for what I'm trying to describe, just because of the nature of the game, like the user-generated content nature of the game. So in Roblox, we can kind of look at that from an architecture perspective. Right now, it's what's called server authoritative, which means it has a heavy server. All of the logic is managed by the server, and the clients are just sending their game events, their player events. So did I press a button? Did I click a mouse? Did I move something around? You just send that to the server. The server figures out what the result is and sends it back to the players. And so you could have lots of players connecting to one massive server or one massive cluster of servers to manage this simulation of the game. And that can get very expensive. I think Roblox in their the last time I publicly saw it was something like $600 or $700 million a year that they're spending on infrastructure. Mm-hmm. So that's the cost of servers. Now, if somebody doesn't have the right architecture, either they haven't put enough money into the server or they haven't constructed what's called their net code, the code that manages the network connections between servers. If they haven't built that appropriately, you get things like stuttering, you get things like no reg on your shot. So you're going to get all kinds of different artifacts in the game that they decrease the value of the game to the player. So it's incumbent on the game developer to figure out what is the best way to architect things so that it is commercially scalable while giving the player the best experience. Because sometimes they have to ask themselves that question, right? They go, do we scale our servers and we don't have enough money coming in? How do we sustain? Right.
Right. And in fact, I have a good real world example of great architecture and also network structure and architecture that I think everybody might lean in on. League of Legends is my example. Mm-hmm. And about 10 or maybe closer to 15 years ago now. So they're server authoritative.
Right.
They have 10 players at a time. The map is going. But one of the things that goes unsung or like uncelebrated is that I can play with somebody in Chicago and not feel laggy. It still feels like a great experience from West Coast to East Coast. And that's not an accident. That's not just build the game and put it on the internet. So what Riot did back in the day is they actually went and created a fast lane for themselves between the different server centers. There's a Handshake in Los Angeles. There's like a big server center in Las Vegas. I think there's one it's like Washington probably. And then Chicago is a huge data center. And basically what they did is they created these network packet fast lanes so that when people are playing League of Legends packets or network packets or information. Let's say, Ken, you're in New Jersey right now. For this example, is basically I left click on my machine that creates a data information. That packet gets sent, between my machine to the server and then the server to Ken extremely quickly. And without that optimization, basically Ken's experience would be like, oh my God, this guy Crisscross is so slow. Like he's so laggy, or there's like bad information coming through. So maybe my animations look choppy. And so the end result from a user standpoint will be potentially visual, but what the problem is actually an invisible network connectivity. Am I in the right ballpark here, Ken? Like, I just want to make sure
So that is part of architecture. It's called network route optimization.
Yep.
It's a huge piece. And if people can do it well, like companies like Akamai built an entire business around this. Mm-hmm. And there's lots of companies that are doing it. I think Clearstream's another one that's doing it. But the idea is that when you use the internet as it is, you're bouncing from internet service provider to internet service provider. So if I'm going from my house in New Jersey to your house in LA, we've probably got a number of hops in between us as you just travel the natural, normal internet. But there are strategies where you can create gateways with these kind of fast lanes, as you would call it, where maybe there's a fast lane in West Virginia and there's a fast lane in LA, and we create a gateway. And what happens is my New Jersey computer talks to the West Virginia computer and immediately just shoots straight to LA and then to you. And figuring out what the network configuration is to get packets from me to you the fastest is like the most direct way to reduce latency in a game.
So here's a question. I know the answer is like, what are situations where you don't care about that kind of optimization? Because it feels like if I didn't know tech that I would be like, well, why wouldn't you optimize everything? But then you would end up in the same thing of like when Waze came out, I was like, oh, my shortcuts are all screwed up because like Waze is now sending everybody to my shortcuts, and then it basically congests everything, right? But they're like, what are some use cases of things that don't need optimization?
Well, that's that whole solution, that whole engineered solution is an expensive solution. It has to make sense commercially for you to move to that model. So Fortnite, for example, or even League of Legends in particular, there's so much revenue opportunity for them. They're masters of Riot's masters of merchandising and IP licensing and all kinds of incredible. And so they've got multiple revenue streams that allows them to do that. And now they can afford, their business model allows them to afford that. I would argue that most games can't afford that, but most games don't necessarily need that. And what I mean by that is in the netcode, you can smooth out some of those hiccups. And the netcode is, again, the code that manages how your game handles the network anomalies that you receive naturally from network connections. And so one way you can do that is you can do something that's called prediction and rollback, for example. This is a very common strategy, which is, I think I know what the game should do next. So on my own machine, I'm going to do that. But if the server ever comes back and says, hey, I've calculated a different outcome, my computer will roll back to that new outcome. And then on top of that, I can create a very smooth experience. You can kind of like feather that so that it feels more natural. And those resolutions usually happen within milliseconds, right? So maybe 100 milliseconds, you're going to get that rollback that says, hey, what you predicted is the next move. So you can think if you're like moving from left to right, you can predict that you're going to continue moving left to right. So your game could pretend like your opponent is still moving left to right. But then the server goes, oh no, they juked and now they're going back to the left. And when that happens, you can do a quick rollback. And so anything that happened that conflicts at that period, like in that 100 milliseconds between them moving from left to right and then changing right to left, was there an attack that happened in that space? Was there some type of collectible they should have grabbed, a hidden collectible or something? You can start to calculate all those things and go, what should have the outcome have been? And again, it happens so quickly. We think of 100 milliseconds and that's the blink of an eye. I think mathematically speaking, or scientifically speaking, I think it's something like 280 or 300 milliseconds is what our kind of perceivable range is. Although we all argue that we need to have 1 to 2 millisecond response times on our monitors. So
yes. What's interesting about that is like Call of Duty Modern Warfare. When it came out, was one of the first games to make 60 frames per second standard, both server side and visually. And it's interesting because I think a lot of people at that time weren't really clued in to frame rate except when it dipped below 30, right? They only noticed the negative. And arguably, scientifically, it's said that like over 30, the eye can't really tell the difference, except that we can. So like when Call of Duty went to 60 frames per second, almost everybody had a perception of higher quality. The science of it means nothing is because everybody felt that way. And the technology was like, why does Call of Duty just seem so much smoother or so much more higher quality visuals, even though they weren't pushing more dense polygons or textures or anything else in multiplayer? They were just basically pushing more frames per second than everybody else would, which gives this perception of like a high quality experience. And now like fast action, big budget games are trying to hit faster, higher frame rates, especially on PC. But that's a great example, just to summate, of something that is done on the back end that is not, consciously noticeable by the player, that gives a subconscious feeling of higher quality that people will express in like, more human terms like smooth or like such high resolution. Or they'll even say things that aren't really have anything to do with the frame rate, but it's their perception is changed by that subconscious piece, right?
Well, and let's think about the different clock cycles we talk about in gaming. So the one that people are most familiar with is what you're talking about, which is your frame rate, right? So if you've got 120 FPS, that's 120 frames per second. But games, when we talk at the netcode level, we're talking in tick rate, which is how many ticks are we sending. This is how many messages are we sending to the server and how many messages is the server sending back. Call of Duty, for example, on the high end is 60 hertz, which is 60 ticks per second, which comes to about 16 milliseconds per message packet. So 16 milliseconds. Most games live in that 20 to 30 hertz area, which is 33 milliseconds in between network communication packets. So even if you've got 120 frame per second monitor and GPU that can handle that, you're still only talking to the server 30 times a second, even though you're generating images 120 frames per second.
Right.
And that's part of the magic of what this is, the artistic side. This is the magic side of game development, is like, listen, we know that you're actually talking to the server about a quarter of the time that you're generating images on your screen. But how do we make the images you generate feel smooth? And how do we mitigate the conflicts that come from the synchronization between the player and the server? And that is netcode. How you manage that is netcode. Valorant in particular. Valorant has 120
120,
right? Isn't there? Yeah, 120. So it's like you're talking to the server almost as fast as you're generating frames on your screen, which means you're going to have very little conflict between the game state and the server state and what you see on your screen.
Right. That's super interesting, because even, let's go to like an extreme. Let me see if I can summate this correctly. There's an interpolation that's going on visually, right? And it's almost like the information is like a single frame of like Donald Duck, stepping forward. And then like, half a second later, you get him in like mid step. And then a half a second after that, you get final step. But basically we're interpolating in between those three frames and still visually making it smooth. And so basically I might be telling the server, Donald Duck just started a step, right? And then halfway through is like, oh, he's halfway done. And at the end of that second, he's like, oh, he's taking a full step. But the server and the client are still filling in the information in between to create a smooth experience. It'd be like, instead of like basically the feeling of stop motion, right?
Right.
So early days Call of Duty was essentially, let's say 4 players join in. There's no real server. There was a matchmaker, but it wasn't server authoritative. So 4 players would get together and 1 player would be designated as the host.
Right.
And basically their console or their PC was determining what information to send everybody else as far as where people are. Did they shoot? Did they not shoot? What position are they in, etc. And back in those days, that first like probably 5 to 6 years, essentially if that person quit, they had to do something called host migration, and they would pass it to somebody else. And then the other part of this, as far as like why peer-to-peer is usually not used in multiplayer games, especially anything that's competitive, is it opened up lots of opportunities for cheating. And so when we say server authoritative, what we're really talking about is like a computer that's not playing the game is essentially acting as the referee, and it determines reality. Right. It says, I don't know what happened over on Ken's machine. I got weird information. So I'm just going to tell him what's going on. And then his machine is going to have to like figure out how to get there. So back in the day, peer-to-peer was a very common protocol and structure for people to set up multiplayer games, because it was actually extremely cheap.
Yeah,
it didn't require too much internet routing or architecture or servers. And, 2 people within a decent proximity on the internet could have an enjoyable game. But it definitely made games between over long distances almost impossible, because then you were at the mercy of your ISP. Well, in 1999, you're at the mercy of your ISP. You were basically like, I can't play with my friends in the Midwest from LA because it's just a terrible experience, right? Then we did server authoritative. That became very common. It became more cost effective. Then it became expected as multiplayer gaming grew in popularity across the gaming space. And now it's extremely rare to run into games that are architected peer-to-peer. And so first, fact check everything that I said. Make sure that I didn't miss any details that you think are important. And then I think that's a great spot for us to launch into what you're working on right now.
Yeah, well, I mean, you're right. I mean, if we go way, way back, I remember using, I think it was the IPX protocol with the Warcraft 2 with my friends. And that was just like, you just have to be on the same LAN. Your IPs have to be able to see each other. Yeah. And then I remember we got BattleNet, and BattleNet actually allowed us to connect for like StarCraft. So I remember going through those phases, and then I think it was really more around like Call of Duty 4, Modern Warfare. I think even Black Ops 1 did peer-to-peer, which was that client host model.
Yep.
Yeah, and so that was all not Treyarch. Who was the Infinity Ward?
Infinity Ward, I think, did the first real multiplayer implementations that were strong.
Well, and if you remember, once we started getting dedicated servers, so we went from that peer-to-peer to dedicated servers, there was a bunch of drama anytime a new title was released in the Call of Duty franchise and it wasn't dedicated servers.
Yes.
Because everybody with a client host. Because to your point, the host becomes the server.
Yeah.
They become the authority of the game. And a host can say, cool, I now have infinite life and infinite bullets. Let's go.
Right.
And so there were people who would literally sit, they'd rotate lobbies. They'd quit a lobby and rejoin until they were selected as host. And once they were hosts, they'd toggle on their cheats. And now they're just speed running through the map and killing everybody.
Even with a console, because what they would do is they would hook their console up to like an intermediary router, and then basically they'd interrupt their signal with like another PC or something, and then reconfigure the packets and send it back out. So you weren't even safe on a console, which most people weren't able to hack at the time. So actually, one other note. So BattleNet actually existed well before StarCraft. I was a tester at Blizzard when BattleNet started becoming a thing. So BattleNet actually was a Diablo thing, because we were trying to get people into multiplayer in Diablo. But I think some Warcraft 2 BattleNet work was done. But at the time, it was definitely like client host. Like, it wasn't popular, right? Like, remember, like internet was early days. People weren't downloading random things in like the early 90s, right? Like it wasn't like, oh, go download this thing. And most everything came on disk. And so for you to get BattleNet, you had to have bought a product that had it with like included. Right. Yep. And like, I just said some things that are going to, like, some people aren't even going to understand. Before the internet, like, you didn't just download stuff. Anyway, sorry. Now back to Call of Duty. In the early client authoritative days for Call of Duty, people had, and they were posting YouTube videos of this, they had what they would call a lag pedal. And the reason they had a lag pedal was it was a guitar pedal hooked up to their network router, and what it would do would be to create network packets to be sent to create traffic on your local network, which would then slow down your connection with whoever's hosting. And then you would then quote unquote be slower, like as far as like the return of packets back and forth. Now, the reason why this was a cheat was basically we were already talking about prediction. Back in those days, TIE went to the slowest. And this actually worked on, I think, the first couple of attempts at like server authoritative too, because basically they were saying like Chris's network connection is a little bit slower than Ken's. We're gonna resolve TIEs in favor of Chris because that'll give him a slightly better experience. But what people were doing was artificially slowing down their connection, becoming the slowest client on the, in the thing. And basically you and I could shoot a gun at the same time. I would hit my lag pedal and win that shootout, right? Yep. Because essentially the server would say, or the host, even if it was client side, would say, oh, Cross has the slowest machine. He's the winner of this. And then you would go back and see the replay and you're like, I didn't even see, he wasn't even on screen yet.
That's right. Yeah. I mean, it was called lag switching or lag griefing. Yeah. And it would, specifically where it became like really useful is when you're crossing an open area, because it would force your character to rubber band. So you'd be like running across an open space, and right before you got into the open, you turn on your lag switch. So you'd step on your pedal, you'd run across, and then you'd step on it again, and the server would go, according to what I can see, he stopped. And you're now still on this side of the wall. But then all of a sudden the server would go, oh, wait a second, he's over here. And it would literally rubber band you across the map to the safe zone. So nobody could shoot you in between. And if anybody shot you while you were standing still, the server on the rollback would go, oh, no, he wasn't there. He was already way over here. So you wouldn't be able to get hit.
Right. From an outside viewer perspective, and rubber banding is a really great like visual for this, it would kind of look like they were running, but they might get stutter steps or hitches and do lots of like back and forth sort of catching up. So like it would look like this weird thing where they would like leave reality, right? Because you're like, oh, they're glitching. And then basically, a lot of people would rage click because they'd see that and they'd understand that somebody was using a lag pedal, and then and they'd be like, oh, cheaters, this guy's cheating.
Well, and I don't know that that's out of netcode yet.
I don't know that it is yet either, but I don't think it's probably as common as it used to be. Right. But also, I'm going to go back and say that that's, a major contributor to online toxicity in games. I'm just going to say that. Cheating or griefing is actually the category, right?
Yes.
This episode is brought to you by Indeed. When your computer breaks, you don't wait for it to magically start working again. You fix the problem. So why wait to hire the people your company desperately needs? Use Indeed's sponsored jobs to hire top talent fast. And even better, you only pay for results. There's no need to wait. Speed up your hiring with a $75 sponsored job credit at Indeed.com/podcast. Terms and conditions apply.
So what do we do? What's like, we need some new technology to deal with that. Like, I don't want to spend money on servers. I don't want to, and I want to make a fast, great experience for games. What am I gonna, what are my options?
Well, I mean, there are a few options in there. I mean, one of them is you can keep spending money on servers and just making that tick rate really high and not advantaging the lower latency folks. I think Valorant does a lot of that. And the goal with that is that you want a very competitive experience. Yeah. And you kind of want to tell people who maybe don't have the best network connectivity or are lag griefing, they're like, listen, maybe this game isn't for you.
Right.
So it's kind of becomes more of an exclusive experience. And then the people who are very competitive are spending a lot of money, spending $1,000 on a network router to prioritize their game packets. Right. They're spending, $300 a month to have like guaranteed synchronous gigabit or 2 gigabit synchronous connectivity to their ISP. And they've got a $10,000 computer. And those are the guys this game is made for. Right. And they move to Austin, Texas or San Jose. So they can be right next to the ISP. Right. So those are the people that game is made for.
Right.
The rest of us, though, we have to deal with network drama, network stutters, network anomalies. Sure. And so one way to do this is to basically cater to the elite group, right? And say, listen, we're not going to give preferential treatment to the lower latency. We're going to write our netcode in a way that really caters towards the high performers or to the competitive scene. Right. So that's one way to do it. It's still expensive because you still have to have high tick rates, which means lots of network communication, which is costly. Yep. You have to have like very fast and powerful servers to keep up with your demand. So it's still costly to do that. And it doesn't get rid of the problem, but it definitely minimizes the problem. And I think you're seeing, big budgets can help solve that problem. But what about the people who don't have the big budgets or going after a more casual gaming audience who have this problem? Really, they're kind of still stuck, and we still see that netcode exploit still happening. The reason for writing netcode in a way where you prefer the higher latency people is because you want everybody to have a good experience. And what you're really saying is you're saying everybody's going to have a slightly less good experience, but at least everybody's kind of equally less good. Sure. Versus the alternative is there's a whole bunch of people who are going to have a horrible experience, but then there's a group of people that are going to have an excellent experience, like a mind-blowing, excellent competitive experience. I think that's part of the business decision of the game, of the audience they're going after. Now, most games aren't that intense. Most games have a casual scene and are really trying to expand their player base. So they do write their netcode in a way that still caters to the higher lag folks. And I don't know this for sure, but I can almost bet if you look at anybody's netcode, there's some algorithm in there that quickly figures out, okay, that was a network anomaly. Let's like give this slowest person a bone and give them a better experience at the expense of everybody else playing the game. Right. Now, the alternative is that we use math to determine what a fair outcome should be. And that's what we've built. So we built an entire algorithm that basically says, we don't even need servers anymore. What we're going to do is we're going to allow the peers to all broadcast their game events to each other. They're all going to witness each other's game events and then run an algorithm in the background that calculates the order of those game events relative to each other. So there is actually a math equation we wrote, and the math guarantees that eventually everybody's going to come to the same conclusion of the order of events. Now, what this means is if I've got 10 players and I've got one person who has horrible network connectivity, they can argue that they should have had preferential treatment. But really what's happening is every time they send a game event, it kind of gets smoothed out in the algorithm and gets put in its fair place. And I can objectively look at an event in a game and say, did you press your A button to move to the left before I press my left click to shoot you? And we can say, and is there at least 20 milliseconds in between those two events? And if there are, then objectively I moved before you shot. Right. And we can look at that stream, and every player is seeing that same stream and calculating the same order and the same distance between events. So I can mathematically show you why that person hit you. Now, that doesn't solve what happens on the screen. What that does is it solves the fairness problem. So we start with a fair base. which is the simulation. And then you have the presentation, which sits on top of it, which is what you end up seeing on the screen. And so the question is, how do game developers resolve those issues on screen?
So actually, before we move into this, let me recap a little bit on like why this math equation is important. So basically, I would say most developers, or at least most indie to small developers, and you don't have a large publisher behind you, and even some of the games that are done by large publishers, depending on what their audience is or their target market, etc., don't take this much care in their network code. They'll take whatever's out of the box from like, Unreal or Unity Photon or something like that. They'll just hook up all the events, like when things happen, tell the server this thing happened, right? And then the server just takes them in order, like a line at a concert. And it's just going like, they came in this order. I don't care when you're time stamped. I don't care that, like, I'm not actually going to solve this stuff. I'm just going to like solve the conveyor belt of like information coming in and put it right back out in a slightly organized order. But essentially, I kind of don't care. And what you're saying is like, no, what we're doing is we're evaluating all of that information and reordering that line of information across time and saying that like objectively, we can all agree that this is the correct order. And what's important about that is that because it's an algorithm, every client can do it for themselves and not necessarily have to wait for the server to tell them it's right.
Well, that's 100% right. So I think that last statement is probably one of the more important parts, because what's happening is we're all blasting our messages. We're gossiping our messages to each other as fast as possible. So we're just saying, here are all of my game events, and I'm receiving everybody's game events. In about 2.5 cycles of that transition, so you can think of in 2.5 ticks, right? Yeah. Between the players in their session, which roughly in a smaller network that are closer together is somewhere in the range of like 24 milliseconds. Yeah. In a larger game that's slightly further apart, it's about 50 milliseconds of strictly peer-to-peer. That's what we're talking about, the time it takes for me to calculate the order of all of these messages I'm receiving, including my own. Yeah. And everybody is independently calculating the same order. And because the math is good, it's almost magic. Everybody calculates the same order.
Right. We're all going to like pencils down, look up, and come up with the same answer. By the way, just like an interesting, like the visual in my head right now of what the server's doing is like in Men in Black 2, where there's that guy underneath the mail sorter with the big eyes, and he's just sending packets out. Like he's that guy, right? Like that's what the server's doing. It's essentially like, what is this? Send it. What is this? Send it. And it's not really putting any logic to it. It just knows that everything goes in a bucket somewhere, right? Or a box. Right. So this is interesting because I think it answered one of my questions, because I was trying to describe what you're doing to a tech director somewhere. And they're like, this seems like it's going to be slower. And then what I realized is essentially it's spending a little bit more time on the client, but less travel time. Yes. Basically, it ends up being a net faster than me sending packets out to a server and packets back.
Well, and let's be concrete about it, right? So if I'm in North Dakota playing Apex Legends, and we'll say Oregon is the nearest server to me, I'm automatically getting 100 millisecond ping off of that, right? So automatically I've got 100 milliseconds before I know if anything has changed in the game. Right. If I'm in North Dakota playing with my neighbors and we have a 9 millisecond ping between each other, then 2.5 is going to be somewhere around 24 milliseconds, 23 milliseconds for us to play our game together, just in the consensus part of it. So effectively what we've done is we've said, instead of us focusing on putting a lot of servers everywhere to try to satisfy everybody, why don't we just match people by how close they are to each other and prioritize that matching so that people can have better experiences near each other. Right. So it's true. If I'm in San Jose and I'm playing with my neighbors, server authoritative might be significantly faster. And by significantly, I mean going from 24 milliseconds down to 5 milliseconds. Sure. Right. So if I'm in San Jose playing with San Jose people, we're at like 5 milliseconds of latency, and it's incredible. Keep in mind, tick rate, you're still looking at like 16 milliseconds on the fastest end for tick rate. Right. So 16.6 milliseconds on the 60 hertz tick rate. Yep. So even if we have fast ping, we still have that tick rate we got to deal with. And what we're saying is like, well, that's great if you live in San Jose or in Austin. Right. Like that's amazing. But what happens when I'm in Indonesia or, I'm out in rural US somewhere where I have a lot of latency to the nearest server, and we're basically solving for that problem. Now, the real question is is that still fast enough? Is 24 milliseconds or even up to 50 milliseconds, right? Fast enough. And this is where netcode becomes really important. And this is where prediction and rollback becomes important, because if you're applying good prediction algorithms on top of it, the player doesn't really feel the difference. The player shouldn't feel the difference much. It still should be smooth. For the majority of the world, the experience improves in multiplayer. This is what we call player meshes, right?
Yes.
You group players together and they calculate the state of the game between each other. We call that a player mesh. Going towards a player mesh model, I think, is more advantageous for the majority of the world. There's a smaller group of people that it's more advantageous to have a server authoritative model,
right? But
you lose fairness. So you still get things like lag switching. You still get specifically host client. Let's forget about that because nobody really does that anymore.
Sure.
But that strict peer-to-peer host client model, if you are doing that, then whoever's the host can actually change the state of the game.
Right.
Well, in a player mesh, you can't. Player mesh, everybody has to agree on the state of the game, number one. And number two, you don't have all of the fairness problems of a server authoritative approach.
So we're in the United States, but I'm assuming this is like hardware agnostic. See, this works on mobile games and PC, etc. So like a majority of the world plays games on their mobile devices. Like not only that, like there's two use cases here. One is like, I'm going to pick a city. Please don't everybody freak out. But like, I'm in Topeka, Kansas, right? And let's just say the infrastructure there isn't as good as San Jose. And so like the server authoritative model at the high end actually doesn't matter there because the infrastructure between the ISP and my house is pretty slow anyway. And so like I'm basically picking up latency just because of the oldness of the network before I get to like the fast lane. I mean, I've seen people in the Appalachians complain about their internet connectivity. Like this is in the rural United States, it's actually super common, is that the infrastructure for internet connectivity is not really conducive to multiplayer games. But this is going to also include lots of infrastructure in, say, like Pakistan and India and West Africa and like all over the world where it's not really well developed. And what you're saying is that this technology should allow all of those people to at least have good experiences with their local community. Now, this brings up my question of like, when I was at Nexon, we had multiple territories, North America, South America, Europe, Asia, etc. Now, those didn't generally mix. Sometimes we would play games with those in Europe, but you can imagine the travel time for my signal was super long. Does this help that? Like if I'm playing with somebody in like Berlin?
I would say that the further you are away from the other people in the session, it actually compounds the problem with player meshes. You really want geographically clustered folks. And by geographically clustered, again, take 2.5 the ping, and that's what your latency is going to be from the protocol. So if the average ping of or we'll even say the highest ping of your group between each other is 50 milliseconds, you're going to get probably 125 milliseconds of latency total, which still could be better than server authoritative, but that's kind of the math that you want to do, is kind of 2.5 of whatever your ping is between the players, the highest ping in your group.
So hold on.
The highest of the 2/3.
Yes.
Highest of the test is 2/3.
So let me put my game design hat on, because though that's a technical limitation, there are sometimes ways to design around those things depending on your game. And so like turn-based game doesn't matter, because basically we can solve that. A slower shooter like a World of Tanks, a World of Warships may actually be okay at longer distances because the actual interaction time is slower, right? So like, StarCraft 2 and like Valorant aren't going to play well from downtown LA to Brooklyn, but TFT will, or like any auto chess situation where there's essentially like pretty set game states, right? And then the other one though is like, why this is important for players is that if I'm playing with a game that has a high click rate sort of expectation, like a Valorant or like League of Legends or something like that, basically you already don't play those games with people in other regions because it's not terrible, but it is optimized. I could play with somebody on the East Coast pretty well, but it stretches pretty thin even just going down to Florida, right? Like it starts to get a little bit more difficult, only because they have a central data center in Chicago and I'm just kind of going from tip to tip. But I generally won't play in Europe, which means that when we design the matchmaking system, in other words, the system that determines who's playing with each other, we can put some parameters around how far people can be for an optimal experience depending on the game type.
Yeah, and I suspect that people are going to do a hybrid approach, right? People
Sure.
are going to say, we're playing a casual pickup game. Cool. Go strictly peer-to-peer, provided that the latency isn't
Yes.
more than 50 milliseconds for the highest 2/3 of the players, right? So you might say that. And then you go, okay, now we're going to competitive mode. Oh, wow, we're going to dedicated servers for that. And we're still going to match people that are close to the servers. So you could have a very hybrid approach to that. And that's what I suspect people are going to do.
So that does bring up one thing, though, is it does present potential business, I'll just say challenges to solve, right? Like basically, here's where game design is going to have to talk with business, because like businesses, of course, is like, well, if you're going to fill those games, you need lots of people in those like sort of geographic
Right.
regions. And like generally, most people just do their ads or marketing. They don't usually do it too regionally. So like early days of your game, I might have 10 people in, but they're spread out, and which is potentially a like bad experience or a poor experience depending on the game, right? So I think there's a cooperation that has to happen here with whoever's wearing the business hat. Even if you're indie, you basically have to take your game design hat and your tech hat off and put your business hat on, right? And
That's
go
right.
like what's going to make a great product? Because on day one, I want it to feel good, or I want it to play well. And basically, you may have to do things like, oh, let's actually do more of a regional rollout, or like I'm gonna go to PAX East and sign up a bunch of players there and get them involved, and then we can solve some of the other problems as we allow more people in with a wider like geographical sort of spread.
Yeah, and if you've ever done an indie or even up to AAA, right? And even some of the AA's and AAA games, like it's really a race. Once you launch your game, it's a race to build your player base
Yeah.
faster than your runway, right?
Yes.
Because if your runway runs out before you have a sufficiently sustainable player base, then the game goes away. It's as simple as that. And I think indies feel that a lot, especially when there's a server involved and they're going, wait a second, I'm paying $5,000 a month for 2 servers, one in the East Coast and one in Europe for my player base. And all of my Asian players are getting screwed right now.
Right.
And I'm getting nothing but bad press because my game sucks. And it's like, but
Yeah.
I can't afford more if I want longer than like a 10-month runway.
Yeah.
So
yeah.
that's the business side you're talking about. And what we're saying is like, listen, if you were to use a player mesh to solve that, if you were to use Tashi's player meshes to solve that,
Yeah.
at least for the indies, you can buy runway with that. You can be like, we're going to add $5,000, $10,000 back into your budget
Sure.
that you don't have to spend on servers. And maybe we have to get more creative with the net code. And again, it always depends on the game type, right?
Right.
Twitchy games are going to be really tough to run with this model, but turn-based or even slow Twitch games.
Yeah. Or I mean, even like something like Castle Crashers, which is 4-player co-op, right? Would
Right.
still probably play very well across long distances, because it's not, the density of animation frames is not as high. The play space is pretty well defined. The amount of interactions is actually really well defined. I think you could write some pretty strong predictive code for a lot of that, right? As far as like, how the 4 players are interacting. And just a quick footnote, Australasia, and I mashed Australia, New Zealand into the Asia thing, because usually like there's sometimes 2 server centers, but there's like who gets screwed the most is actually like Australia, New Zealand in these situations, because people tend to pick like a server that's more centrally located, like Singapore, Malaysia, like in that sort of zone, or like South Korea. It's pretty messed up. And actually South Koreans are spoiled because they went high speed infrastructure when they retrofitted for the Olympics. So
Well done, Korea. Well done.
yeah, they wired everybody.
Yeah.
They just said,
I
"Well, just do it all."
It's my second home. Yeah, Korea is
Yeah.
my second home, and I
Yeah.
love that place. Yeah,
Well, there are websites in Korea that don't run here. Like you can't run them here. Like the throughput just won't handle them. They're just too dense.
oh, that's incredible.
Like, so they have to like dumb down websites to be like, literally we
That's
have to
too
build
funny.
different websites than are what are being shown. Like, it's not just a localization issue. It's actually a fresh website for games that are launched in Korea that come to the States, or at least it used to be. I think things are faster now. We have more fiber, we have X, Y, Z, but that still doesn't help, poor Jeff in Topeka, who's, like crawling around on 5G.
That's right.
Okay, so we're about out of time, but I would love to ask you back. Like, I know this is not directly related to what you're doing. By the way, go see what we're talking about. Is it GG?
Yeah, Tashi.gg is the first stop.
Especially for those tech heads out there, jump into that. Most regular players just don't bother. We'll just make it play well for you. I want to have you back, and I know this is not directly related, but I want to talk about qualitative matchmaking because we brought it up a little bit here from geography. But my little side story is that toxic players, when I was at Nexon in most games, didn't actually get banned. They actually got sent to Prisoner Island. So toxic players would get match made with other toxic players. And by toxic, I'm including cheaters. And this was especially relevant to cheaters. So we would send combat arms cheaters into servers with other cheaters. And it was interesting because it was kind of like they were kindred spirits. They're like, oh, you're cheating. They're like, you're cheating. Like, oh, we're all cheating. Okay, let's have fun cheating. And then basically it was essentially finding a demographic cohort, and they would have fun together, which means that they were still spending money. Like they weren't spending regular money, but they would be like, oh, I want to get the new thing or the skin or the whatever, because they had a new social cohort, and it was all people who were like, rules are malleable. And so like instead of eliminating, you know, some very small percentage of the audience, they actually made a small percentage of the audience like fanboys or like really happy because they're like, oh, well, yeah, I can go play normal, but when I want to cheat, I can go to these cheat zones with my other cheaters and we can talk recipes for how to cheat better.
But that's a whole game in itself. I mean, like even my son and I play Minecraft totally different. I'm like, I want to play survival only. I want to play from scratch. I don't want any special cheats or anything. And my son's like, I only want to play creative. And I'm like, why would you play creative? But it's the same feeling. Like I'm playing Apex Legends because I want to get better at like mouse control and flick shots and no scopes. And if you got a cheater in there, they want to play because they want to overcome the system. Right. That's their problem they're solving. Yes. They're like, how can I use code and exploits and things like that to overcome the rules of the system? I'm like, that's a totally different game you're playing. Right. Go play that game. I wish you the best, but just don't play it while I'm playing my game.
Totally. And that's the split. But yeah, when we talk about matchmaking, I'll save that for then, but I'd love to have you back on so that you and I could talk about that, because like I've been dreaming of designing, well, I've kind of got it designed, but building qualitative matchmaking for multiplayer games that's a little bit more of your personality into effect, you know, and like how you want it, because what you just identified is two play styles, and that's where I want to dig into is like take play style into account and put your unspoken goal of I want to survive and see how long I can go in Minecraft versus creative mode. Those are two different players that are looking for a different experience. And I think we can do a better job of matchmaking. So like, I don't play a lot of multiplayer games right now because of rando matchmaking. Like not everybody's doing the same thing I am. Awesome. Thank you, Ken. Until next time, this is Brain Arcade, and we'll talk again. Brain Arcade is a Princess Hermit production, produced by Kyrene Kim, music and mixing by Jonathan Ontiveros. The podcast is hosted by me, Chris Cross. You can find me and my other endeavors at coffeewithcross.com.
Electric acid.